Now we're going to find an inverse of a function and graph it to prove that they are inverses. So we're going to use example number 3 because it uses a quadratic, and the inverse we think will be a square root function. So this first, we know it is the parent function parabola, but shifted down 4 units. So I'm just going to use my transformations to know how to graph that. And it should look like this. If you wanted to make a function table, you could, or find the vertex or any other type of graphing. Now let's find the inverse. We're going to change this to y equals x squared minus 4, and then switch x and y, and then we're going to solve for y. Add 4 to both sides, and you get x plus 4 equals y squared, and then take the square root of both sides, and we get f inverse of x equals the square root of x plus 4. And we can graph that by shifting it to the left 4 units of the regular square root function, up over 1 and up 1, over 4 and up 2, over 9 and up 3, and there is our square root function. So something that's interesting is that when you do graph this, it ends up kind of cutting off the bottom half of what would be the inverse of a parabola, but they're still reflected across y equals x. It's like a sideways parabola, but the bottom half is cut off. Now, this is the worksheet that we did in class, so if you need help, I'm going to go over a few of them now. It says describe the transformation. I told you that there would be one on our test like this. So for example number 1, the 2 shows a stretch by a factor of 2. And the negative 9 on the outside of the radical shows that you're shifting down 9 units. Okay. Here the negative shows a reflection. Plus 5 inside of the radical shifts left to right, but it lies to you, so it's left 5 units. And then the 3 shifts up 3 units. Okay. Here it says the square root parent function, so automatically I'm going to draw a square root equation, y equals the square root of x. It's vertically compressed, meaning there's going to be a fraction out front by a factor of 1/3. So that's going to be my coefficient. Then translated so that it has an endpoint of 4, 1. To the right 4 and down 1. So this is going to be minus 4 since the inside lies, and minus 1. And that would be your function. Okay, in number 6, notice I changed it to a cube root just so that you got experience doing a square and a cube root. For number 5, this is the square root function, but shifted down 4 units. And then we always go over 1 and up 1, over 4 and up 2, over 9 and up 3, from the endpoint. Here my endpoint, since it's a square root function, is 0, negative 4. The domain is from 0 to infinity, and the range is from negative 4 to infinity. As x approaches infinity, as we go to the right, f of x also approaches infinity. But as we go to the left, as we go from the right side towards the left, we're going this way. We're not approaching infinity anymore. We're approaching this line right here, this dotted line, which is 0. So as x approaches 0, we approach negative 4. And this is never decreasing, it's always increasing, and the domain is going to tell you where it's always increasing. Okay? That's pretty much it for that page. And then you had a second page. Here it asks you to prove that the two functions are inverses. I'm going to do number 8 since it has a square root and a squared function, a quadratic function in there, rather than doing the other ones. So we're going to do f of g of x and hopefully get x in the end. And then we'll also do g of f of x and hope that we also get x in the end. So my function f is x plus 4 plus 9. But everywhere I see an x, I'm going to replace it with g of x, which is x minus 9 squared minus 4. The negative 4 and the 4 cancel out, and you're left with the square root of x minus 9 squared plus 9. The square root cancels out, and you're left with x minus 9 plus 9, which cancels to be x. So that works so far. Now you have to do the same thing, but take g, and everywhere you see an x, replace it with f of x. So the 9 minus 9 cancels, and you get the square root of x plus 4, squared minus 4. The square root and the squared cancel, and you get x plus 4 minus 4, and it works. Yes, they're inverses. And these are like the examples we did above. So hopefully that helps if you were absent today to go over some of this. The only other thing that we did was the Math Nation book, so make sure you have pages 171 to 183 complete when you come back, and we have a test next week.